Hey guys, so today we're going to be talking about the surface area and volume of a sphere. Before we start, I want to talk to you guys about what a great circle is. A great circle is a circle on the surface area, or on the surface rather, that lies in a plane passing through the sphere's center. Okay? So what that means is it's basically the largest circle that you can draw around a sphere. Okay, so like if you look at this diagram shown below of the sphere, you can see that this right here is the largest possible circle that you can draw, right? Now, obviously this has an infinite number of great circles, right? But what's not a great circle would be a circle that's drawn like here, right? So it has to be on a plane that goes through the sphere center, right? So if you were to draw a plane, kind of like a cross-sectional, that we talked about in a few lessons earlier, if you were to draw a cross-sectional, it would have to go through the center of the circle. So this would not be a great circle. This right here would be a great circle. Okay, so continuing on, let's look at the surface area of a sphere. The surface area of a sphere is S equals 4 pi r squared. So you're just going to do 4 times pi r squared, and that will give you the surface area of a sphere. The volume of a sphere is going to be 4/3 times pi times r cubed. Okay, so that's going to be the volume. Now let's look at some examples here. Make sure, by the way, make sure that you guys are pausing your video at least after every couple of questions so you can try it yourself. That way I'm not just, doing it and you're just watching. Like, that's not going to help anyone. Make sure that you're trying it, you're attempting it. So anyways, looking at question 1, we have a sphere with a radius of 5 centimeters. It asks us to find the surface area. So I know that the surface area of a sphere is 4 pi r squared. So I'm going to do 4 times, my radius squared is 25, so I'm going to do 25 pi. I end up with 100 pi, which then makes S approximately 314.16 centimeters squared. Centimeters squared because this is surface area, it's not volume. For this next one, we're given the diameter is 9. That means the radius would be 4.5. So again, I'm going to do the same thing. So I'm going to do 4 times pi r squared. So it's going to be 4.5 squared and then times pi. When you plug that into the calculator, you get that S is approximately 254.5 centimeters squared. Okay, so if we look at questions 3 and 4, these are actually hemispheres, which means that they're half of a sphere. So that circumference of the bottom is actually going to be a great circle. Now, I want you guys to be very careful when we're talking about surface area. Surface area, as we mentioned a few lessons back, is going to be the area, the lateral area plus the base, right? So it's basically the area of every part of the figure. Now, in this case, we have the lateral area, right? So we have that top part, but we also have this base that we have to worry about, right? So what we're going to do is we're going to find the surface area of half of this sphere first using the 4 pi r squared, but then we would just divide it by 2. But then in the end, we're actually going to be adding the base, which has a radius of 1. So let's look at this. So the first thing I'm going to do is I'm going to do my surface area of this is going to be 4 pi r squared well, this is just the top part. It's actually, I'm going to just call that the lateral area, divided by 2. Okay, this simplifies to lateral area equals 2 pi r squared. Okay, so let's do this first. When we do this, we end up with 2 times, now my radius here is actually 1, they give us the diameter, so it's going to be 1 squared, which is just 1, and then times pi, so that's actually just going to be 2 pi. Next, we need to find the area of the base. So the base is going to be pi r squared. Now I know that my radius is 1, so 1 squared is just 1, so then my base is just pi, right? So then I'm just going to add my lateral base, because I know that the surface area is going to be my lateral area plus my base. So then I have S equals 2 pi plus pi, which gives me 3 pi, which then simplifies to 9.42. So 9.42, and this is feet squared. Okay, go ahead and try this next one. I would recommend that you pause this video and then try it. Okay, so now let's go ahead and go over question 4. You should have already tried it. So once again, I know that because this does have a base, I'm going to do the lateral area of this sphere, and then I'm going to add the base. So I know that the lateral area, as I've kind of seen before, is going to be 2 pi r squared, okay? And then the base is going to be pi r squared, and I'm just going to add the 2. So for my lateral area, I'm going to do 2 times pi times 11.2 squared, okay? And then for my base, I'm going to do pi times 11.2 squared. Then I'm going to add the 2. So my surface area is going to be 2 pi times 11.2 squared, and then plus my base, which is pi times 11.2 squared. Now, whenever you end up putting this in the calculator, you do end up with your surface area is approximately 1082.24 meters squared. All right, moving on. So for these next few exercises, we're going to be finding the volume of the spheres. So for this first one, we're asked to find the volume whenever the diameter is 15 inches. So I know that the volume of a sphere is 4/3 pi r cubed. Okay? So I'm going to go ahead and do this. So I've got 4/3 pi, and then my radius is going to be half of my diameter, so that's going to be 7.5 cubed. Whenever you plug this into the calculator, you get that your volume is approximately 1,767.1 inches cubed. This is the volume, so make sure that you're using cubic units. So for question 6, I would recommend that you pause the video and kind of try the rest of these problems, and then unpause and see how it's done. Okay, so at this point you should have tried these problems. Let's go ahead and go over them. So for question 4, once again, I have volume equals 4/3 pi r cubed. So I'm going to go ahead and plug in what I have. So I know that volume is 4/3 times pi times my radius, which in this case is 13. So I'm going to do 13 cubed. Whenever I plug this into the calculator, I get that my volume is approximately 9,202.8 cubic inches. Looking at question 7, once again, I'm going to do the same thing. So I've got volume equals 4/3, and then pi times my radius squared. So in this case, my radius is 3.5, not squared, cubed. And so I have this. I'm going to go ahead and plug that into the calculator. When I do, I get that my volume is approximately 179.6 centimeters cubed. For question 8, once again, this time I'm given the diameter. I know that the radius in this case would be half of the diameter, so it would be 5. So I have volume equals 4/3 times pi times 5 cubed. So then once I have that, I can go ahead and plug that into the calculator, and I get that my volume is approximately 523.6 cubic inches. Okay, so for this next part, we're asked to find the diameter of a sphere with a surface area of 144 pi. So first off, we know that the formula for surface area of a sphere is S equals 4 pi r squared, right? Okay, so I'm given everything that I need to know. I'm given that the surface area is 144 pi, and that equals 4 pi r squared. I'm trying to find the diameter, but before I can find the diameter, I need to figure out what the radius is. So I'm going to go ahead then and use some basic algebra. And, oh, what happened there? And I'm going to go ahead and divide out the 4 pi on both sides. I end up with radius squared equals 36. I'm going to take the square root of both sides to get rid of that squared. So I would get radius equals 6. Now, that's just the radius. The diameter would be 2 times 6, so my diameter would be 12 centimeters. All right, moving on. So for this next part, it says find the volume of a sphere with a surface area of 256 pi square inches. So we're actually going to have to use a little bit of both. We have to know both the formula for surface area, which is S equals 4 pi r squared, and we also need to know the volume of a sphere, which is 4/3 pi r cubed. All right, so let's start off with what we know. We know that the surface area is 256 pi, right? So I'm going to go ahead and plug that into what I know. So I know this is going to be 256 pi equals, and I forgot to include the r there, sorry, 4 pi r squared. Okay, so once again, I'm going to go ahead and solve for r, solve for my radius, by dividing the 4 pi out on both sides. So then I get that r squared is equal to 64. When you simplify 256 pi over 4 pi, you get 64. So then I'm going to take the square root of both sides. I get that the radius is 8. So now I know my radius is 8. Now I can figure out the volume by plugging in the radius, right? So I'm going to do volume equals 4/3 times pi times the radius, which in this case is 8 cubed. And I'm going to simply plug that into the calculator. When you do that, you end up with approximately 2,144.7. Okay, for this next part, it's asking us to find the volume of a sphere, this time with a surface area of 400 pi square feet. So once again, I'm going to start with what I know. So I know that my surface area is 400 pi, and I know that the volume of a surface area, that's equal to 4 pi r squared. Okay, so with that, I'm going to start off by finding my radius. Once again, I'm going to divide both sides by 4 pi. These cancel. You're left with the radius squared equals 100. I'm going to take the square root of both sides. I get that the radius is 10. Okay, so with that, I can find the volume. So then the volume would be 4/3 times my radius 10 cubed times pi. So then I get that the volume is approximately 4,188.8.